Welcome back, you guys. I know you're already pumped up to do another proof. Yeah, get excited. Okay, so again, we're still trying to prove that these two triangles are congruent. And this time we have some different information that's given to us. So let's see what happens. And again, make sure you set up your little T-chart, your little, table with your statements and your reasons. Okay, so I know that G to the K segment GK is bisecting angle JGM. Okay, I also know that GJ is congruent to GM, which I already have marked in my picture as congruent. So guess what, you guys? Let's get going on this proof and let's see where it takes us to. So remember, we're trying to show triangles are congruent by SSS, SAS, ASA, or AAS. Okay, one of those shortcuts will show us that these two triangles are congruent. Okay, let's get going, which we always start with the given, which I just heard you guys say that, so nice job. So GK bisects angle JGM, and I'm going to put a and symbol. I'm kind of out of space. Whoops. GJ, it's hard to say that. GJ, try saying that. GJ, hard to say, is congruent to GM. And this is all because of the given. Holy hot dog, right? All right, let's get going. Guys, so it's always good if you can use any key phrases from either a previous statement or the given. That might help you to keep going. So do you guys spot anything in the given that might help you show that some other angles or segments are congruent? What do you guys think? Well, I see this keyword bisects. So take a look at that nifty note sheet that I gave you and look up what it means to be an angle bisector, because this is bisecting an angle, which means it's an angle bisector. Precisely, you guys. So an angle bisector, what it does, it slices the angle in half. It's quite vicious when it does it. And when it slices it in half, it will create two congruent angles. So I know that these two angles will be congruent. So I can now say that angle JGK is congruent to angle KGM because of your definition of an angle bisector. That's what it means to be an angle bisector. So definition of an angle bisector. Okay, so I don't have any other key phrases to help me, which is a problem. Because so far, I just have a side and an angle marked congruent. I don't got anything else, you guys, which is a problem. Okay, and I must show that these two are congruent. I have to. It tells me to prove they're congruent, and I don't want to let my proof down. Okay, so since I don't have anything else I can do, now I need to be searching for one of those tricks up my sleeves. So we got a reflexive side, we have vertical angles, or we have the third angle theorem. Do you guys spot any of those tricks up my sleeves? Whoa, I see a shared side. Just like in example 17, we also had a shared side. Guys, so the shared side in my picture is segment GK. So I can say GK, whoa. Sorry, I'm messing up my color coordination. Sorry, guys. GK is congruent to GK. Okay, it's a shared side, so I can say that it is congruent to itself. And it's always good to mark in your picture, because that way it kind of helps you visualize what is marked congruent in your picture, so then you know if it's SAS, SSS, AAS, or ASA. All right, and since something is congruent to itself, or it's a shared side, this is by the reflexive property. Again, nice. Okay, you guys, I have three things now marked in my picture, which is usually a good hint that my triangles are now congruent. Unless it's the restricted SSA with the fire-breathing demon cat, so watch yourself. Or the angle. AAA again, it will not help you with triangle congruency. Okay, so again, you start from your outermost edges and you kind of work your way around the triangle and see what you spot first. Okay, so I see a side, then I see an angle, and then I see a side. So this triangle has the SAS markings. Okay, let's see if my other triangle has the same markings. I'm going to start, it doesn't matter which one of these I start from. I have a side, then an angle, then a side. So this would be side, angle, side as well. Oh man, you guys, that means my two triangles are now congruent by the SAS postulate. So I'm going to say triangle GJK is congruent to triangle GMK by the SAS postulate, or the SAS postulates. All right, you guys, well, guess what? That's it with that one. But don't you worry, we have another proof awaiting us, so get excited. Nice job, you guys.